Welcome to the 8th mini lecture of 7505 NSC Project Management. The previous lectures we've been talking about the cost and the schedule, and of course particularly scheduling. This is the way in which the project manager actually finds out how to join all the activities from the work breakdown structure into the best arrangement. And scheduling itself is an art, and of course the one thing is we know there are lots of software tools that project managers and their staff in the project planning and control can use. But the one thing is that to use those software tools, we need to understand the principles behind scheduling, or else it's a case of garbage in, garbage out. And that's what we're going to do in this lecture. We're going to talk about project scheduling, establishing networks, putting in duration estimation, and also establishing the critical path. That's a question to say, well, what's a critical path? Well, we'll find out soon, and we'll find out why it's so important that when someone says, I need some extra time for my activity as part of the project, the first question the project manager will probably ask is it on the critical path? We'll find out why that's so important. So what we're going to be doing is describing and applying project scheduling and key terminology. We're going to explain and apply how project networks are developed, using the labelling of nodes, serial activities, concurrent activities, merge and burst activities. We're going to describe and apply duration estimates and networks. And we're going to describe the critical path concept and its use in projects by calculating the network and using a concept called forward and backward passes and laddering and hammock activities. So this is a very applied part of the course where in fact you actually learn by doing. That is, we talk about the theory, but you'll get plenty of opportunities to put the theories into practice to develop simple networks. And once you understand how these networks work, then of course straight away you can then go and use the software tools. Most of them are pretty intuitive and easy to use, and therefore find as to how you can speed up the process of scheduling. Let's say you look at a project planning definition. Project planning is the identification of project objectives and the audit activity necessary to complete the project, including the identification of resource types and quantities required to carry out each activity. That's from the Project Management Book of Knowledge. And of course we said in the first lecture that in the project life cycle of conceptualisation, planning follows that and planning precedes execution. So this is why it's so important. And the key terms in the definition are audit activity, which points towards the scheduled goal itself, and the project scheduling defines the network logic. That is, it's a little bit like, let's go back to building a house. You obviously can't put the roof on until you've put the walls of the house up. And so this is the thing. Everything has to be sequenced in a certain logic. Let's take an example. Let's consider an assignment that you do at the university. Let's assume that the assignment also has a presentation. That is, you write your essay or report and then you have to give a presentation on it as well. Not unusual in the university, and it's something that students might have done in other subjects. And the one thing that we know is that there are two ways of doing it. We can either, once we know the activities, and let's take a look at these activities of identifying the topic, researching it, doing the paper draft, editing the paper, doing the final draft, preparing the presentation, finishing the presentation. If we just strung all of those together, it would take a lot longer. But the one thing we find is if we go from a serial path to a non-serial path, that is, once we got the paper draft, we can then start editing the paper, but at the same time preparing our presentation. So we get into parallel paths. And it's the same when we build a house. That is, when we're actually doing the fitting out of the house, we can have the electricians working at the same time as we've got the plumbers working. We don't wait for one to finish before the other one comes in. So this is an important part of our project management. And we'll be going into lots of terms to understand the network itself. If we consider network diagrams themselves, first of all, they show the interdependence amongst tasks. That is, for example, you can't put the roof on, as we said, without putting the walls up. And you can't put the walls up until you've got a foundation to build it on, or a floor. So that's the interdependence. It facilitates communication. People can see this is where I do my activity and it's preceded by this activity, so I'll stay in contact with that person, and also it's followed by another activity where I should tell that person as to whether I'm going to finish early, on time or late. It helps to schedule the resources, so we make sure that the people and the materials are in place at the right time. It helps determine the project completion, that is, if we know the actual time for the different activities and how they're sequenced, whether they're serial, parallel, we can work out when we're going to finish the project. And most importantly, it identifies the critical activities, that is, those activities where if they actually increase in time to complete them, it extends the time for completion for the whole project itself. And finally, of course, the diagrams show the start date and the finish dates. Two important things in the definition of a project and two important dates of vital importance to the project manager. And the other thing, of course, is that we will cover the different types of ways of representing a network. And we'll talk about activity on ARC, where in fact the activity is actually shown on the arrow itself. And we'll talk about activity on node. That is, the different nodes, such as we have here, B, C, D and F, are the actual activities themselves. And of course, for this lecture itself, we'll be focusing on activity on node. When we come to duration estimation, we said in an earlier lecture, it's the really hardest thing to figure out. And of course, we've got different ways. We can use past experience, as we spoke about in parametrics when we spoke about cost estimation. We can go along to an expert who's done this plenty of times before and absolutely knows it back to front. And there's another way we can call the beta distribution, just another fancy name for a simple formula where it says, work out what you think is the likely time it's going to take, then work out the most pessimistic time, then work out the most optimistic time, and then using the formula where we add the most optimistic to 4 times the most likely plus the pessimistic and divide by 6, and that's going to give us a pretty accurate estimate duration. And we'll do problems where we actually do that. The other thing is we'll show how to construct a critical path. And here's a typical table that shows a project talking about a company that's taken on the job of actually going out there and doing a survey of potential clients and then giving a presentation to the customer on what the survey found out. And here we can see the activities that are defined, their description, such as contract signing and questionnaire design, the predecessors. Now, no computer is going to help you do this. This has to be done by a person. Just as I said, you can't put on the roof before you put up the walls. You can't put up the walls until you've got a floor or a foundation. That's what we mean by predecessors. And here we've got the estimated duration, and this one could have been calculated using the formula of the previous slide. And now we come up against the definition of the critical path. It's the longest path from end to end which determines the shortest project length. So here we see a network that's been developed using that table from the previous slide. And we can see the different activities, A up to H, and we can see them defined, contract, design, market identification, developing presentation and so on. And also we can see the times actually shown in there according to a certain way of representing activities on the particular node itself. And so the one thing that we can see is from A going to B and C, we call it a burst activity. That is, we're going to parallel activities and we call that a burst. Whereas when activities come back in together, we call that a merge activity. This is part of the definitions we learn. And of course we can see that there are a whole range of different paths we can get going from A up to H. We can get ABEH up to ACGH. And if we add up those times, for example, ABEH is 5 plus 5 plus 6 plus 2 is 18 weeks. And as we go down, we can see each path is worth 29 weeks for path 2, 30 weeks for path 3, and 22 weeks for path 4. And we said the critical path is the longest path. So A, C, D, F, H of 30 weeks is our critical path. That is, if the time increases for any one of those activities, it will extend the time of the project. Whereas if we can see A, B, E, H, we might develop the presentation going from, say, 6 hours up to, 6 weeks up to 8 weeks. So that would only increase it to 20 weeks. But anything on the critical path, if it increases by even 1 week, blows out the time. And so that's part of the concept that we'll be studying. So critical path is shown here. Here we can give another table showing the different activities. Here we see what we'll be teaching in the actual lecture as to the way in which we set out the information on each node. And here we can see that we have the different nodes going from A up to K, as shown on the table. The network has been developed according to the predecessors shown there, and we'll be talking about that in detail during the lecture. And you can see the time shown in activity duration on each of them. And by combining rules of the forward and backward pass, sounds a little bit like football, but it's a simple rule, we can actually work out, first of all, the earliest start times and the earliest finish times, shown at the top of each square. We can work out the latest start and the latest finish, shown at the bottom. And the one thing that we know after that is that the difference between the early start and the late start is the float, or the slack. That is, how much time we have to play with. And this is important for project managers. We come up against the concept of laddering activities. And laddering is simply a way of saying, if we had 3 activities, A, B, C, of 3 days, 6 days and 9 days, as a serial we can see that takes 18 days. But if there's a way of breaking A down, so after the first day we can then start B and break them down such as this way, we can see using the rules of critical path that we've discussed earlier, that with a laddered activity like that, we can actually reduce from 18 days down to 12 days. And this is one of the tricks that project managers can use, and this is what we'll be covering in our lecture. So in summary, you can relate to, first of all, the fact that we can apply project scheduling and the key terminology, and we've discussed just a few of those key terminologies. We can explain how projects are developed using the labelling of nodes, and we saw the labelling format, serial activities, concurrent activities with mergers and bursts. We described and applied activity duration networks using our formula of optimistic, pessimistic and likely. And we've described the critical path concept and its use in projects using the different rules where we can calculate the network path times, working out the critical path, and we apply the forward and backward passes and the concepts of laddering and another one called hammock. These are practical exercises that help you understand the software that you may use in a job in the future. They are fundamental principles towards understanding the actual network itself. And this is something that can be extended on in the next lecture. Thank you.